Of course, our life would not be complete in calculus unless we have some type of application. And so for that, we're going to go back to half-lives and drug dosages. And I'm sorry, this should be topic 5. I'll fix that for future semesters. So we have a doctor prescribing a 100 milligram dose of an antibiotic to be taken every 12 hours. Furthermore, the drug is known to have a half-life of 12 hours, almost like that's why they're telling you to take it that way. That is, every 12 hours, half of the drug in your blood is eliminated, right? Your kidneys purge it, your liver, etc., right? Okay, so we're going to find the sequence that gives the amount of drug in your blood immediately after each dose. Find both a recurrence relation and an explicit formula. Okay. Well, to do that, I think it'll help if we kind of think about how this is going to work. All right, so N at time 1, which is the first dose, right? We will take the dose and we will have 100 milligrams in our body, right? No problem. All right, now at time 2, 12 hours later, right? Dose number 2. So if you like, you can think of these as dose number, right? Dose number 2, you've purged half of this. So half of the 100 is gone. So you only have 50 milligrams of the original dose left. But then you take another dose of 100, which gets you to 150. All right. Then at time 3, your third dosage, you have half of that left. Well, half of 150 is 75, and then you take another dose of 100, which gets you 175. At 4, you have half of that left, which is 87.5 plus 100, which is 187.5. Well, I think the recurrence relation is pretty obvious because I think we are using it in order to build this. I mean, maybe I'm going wrong on that, but let's see if I can get you guys to see it. So the recurrence relation, I think, is pretty easy. So recurrence would be, relation. I'll give it its full title. Recurrence relation. At dose 1, we have 100. And the next dose is the last dose divided in 2, right? The last value divided in 2, plus 100, right? We took the next value, right? To find the next value, we took the last value, divided in half, and added on 100. Took that value, divided in half, and added 100, right? That's what we were doing, right? Because of the half-life issue. So that's the reason we're dividing by 2, because it has a half-life of 12 hours. So every dose time, it will be half of what it once was. So we're taking the last value and dividing it in 2. All right, that's not so bad. The harder bit to see is the explicit relationship. Remember that if we're multiplying or dividing by the same amount every time in the recurrence relation, that means that this is geometric. And if it's geometric, that multiplying by a half, right, because it's dn times a half, that will be the ratio, which will be the base of our geometric sequence. So we know that the the explicit formula, which is a little bit complicated, but bear with me here, that explicit formula will definitely have a half in it, for sure, right? So it's going to be d sub n is equal to, and there will be something involving a half to the n power in here. It has to be, right? That's how geometric sequences work. We know that since we're dividing by 2 every time, that will make it geometric, and r will be the base of something. All right, well, we're obviously not just dividing in 2, right? Because it's not shrinking. I mean, this bit shrunk from 100 to 50. All right, let's think about this for a second. If you just took 2 doses, how much would you have? Well, you've had 200, right? So what you'd have is 200, right? If you just took a 100 milligram pill plus another 100 milligram pill. But the trick is that in between, you've lost some of it, right? So it's 200 times, well, you could say minus 200 times 1/2 to the n, or you could say 200 times 1 minus a half to the n. right? You'd have a full 200 milligram dose because you took 100 plus 100, except that you lost some of it, right? So it's 1 minus a half to the n. Now, check me out and see if I'm right. I mean, I know I am, but by all means, let's check me out. So let's go to Desmos and see. All right, so I'm going to insert a table. I'm going to call this N1. And then let's try what I just typed. So I said it's 200 minus 200 times a half to the n. Like that. Let's see if it works. At 1, you get 100. At 2, you get 150, 175. Oh, look at that. It's working, right? Or you could also write it as, let me go over here. I'm trying to get over to the right. Come on, Desmos. Do what I want. There, I got it. It's if you click too far over to the right, it doesn't know what you want to do. It's too far over. So I could say 200 times 1 minus a half to the n1. Same values, right? It works, right? Because 2 pills together would get you 200, right? And that's what you took in those 2 doses, right? Between 1 and 2, or between 2 and 3, between 3 and 4, you're taking 200 milligrams intake. But the trick is that you're losing 200 times a half to the n, right? You're losing because of the half-life of the drug. And I have to start at 200 because, of course, I have to make the 1 work out, right? So if I'm going to make this formula work, I have to take 200 minus 200 times a half, right, to the 1, and 200 times a half to the 1 is 100, and that'll make it so that 200 times 1 minus a half is 200 times a half, which will make 100 work. So it's geometric because we have this 1/2 to the n power, but it's a little bit strange for a geometric, and this is the way half-lives, if you will, work. This is how they function. So what's the value you're heading towards? What's your steady state level, right? Which is what we are talking about right down here, right? As I go larger and larger and larger in the sequence, and you can kind of see it right here. I mean, I didn't do 5, but I can. As I recall, it was 190 something. I'll go check it in Desmos. It was 193.75. So it'd be 93.75 plus 100, which is 193.75. And you can see we're getting closer and closer and closer to 200, right? What 2 doses would be. All right, so I would speculate that the limit as n goes to infinity of d sub n is 200, which just makes sense. I mean, look at it. If you let a half to the n go to infinity, this is going to turn into 0. 200 times 1 minus 0 is 200. So here I can even do this. It'd be 200 times 1 minus a half to the infinity power. A half to the infinity power is 0, right? That's the same thing as 200 times 1 minus 1 over 2 to the infinity, which is 200 times 1 minus 0, which is 200. That's the steady state, right? In your bloodstream, the reason your doctor has you take it every 12 hours is they're trying to get you to this steady state of having 200 milligrams in your blood, right? That's why when you take pills, if you've ever taken things like a Z-Pack or an antibiotic pack, what they'll do is they'll tell you take it every 12 hours, take it every 24 hours. Those are calculated based on half-lives of the drug that they're giving you. Right, they're trying to get you to a steady state. And if you miss your dosage, you're basically making this sequence go wonky and making the amount in your blood not be the consistent level it needs to be in order to fight off the infection. Oh, and I actually just did this. I'm sorry. I found the limit of the sequence directly. It's right here. I apologize. So finding the limit of the sequence directly is right there. I did it.